Ladies and gentlemen, welcome to section 11.1, Inverse Variation, Part 1. We're going to start off with a vocab word from linear algebra, and it is direct variation. Direct variation is an equation y equals kx, where k is a non-zero number. That is the important part, because if k was a zero number, we really wouldn't have this equation at all. So this table represents a direct variation equation. So let's go ahead and take a peek at what the graph would look like. Well, we have to graph these numbers. So we graph 2, 1. So you go over 2 on the x, up 1 on the y. Over 4, up 2. Over 6, up 3. And over 8, up 4. Let's go ahead and connect these dots with a line. So we connect these dots, and what happens with our graph? Our graph turns into a straight line, but more importantly, our graph goes through coordinate point 0, 0. So a direct variation equation goes through coordinate point 0, 0. If it does not go through 0, 0, it is not a direct variation. Let's take a peek at what our equation looks like. Well, here, y equals kx. This is our equation, so we're going to use y equals kx. What are we given here? We are given x and y, so you can pick any x and y's. I'm going to pick 4, 2. You're going to plug these numbers in for x and y. And now, how is this 4 attached to the k? Because we want to solve for k. So if we solve for k, we're going to divide by 4. So now k equals 1/2. And then if we were to write an equation with k, we just plug k, or 1/2, in for k. And so y equals 1/2 x. And this equation represents this graph and this table. Now we have inverse variation, where y equals k over x. Or you could also have x times y equals k. Important part to notice here, that k either is being divided by x, or a number is going to be divided by x, or x times y will equal a number. X times y equals a number. Let's take a look at our table. So our dots are already laid out for us, because I didn't want to draw all these dots for you. But now we have -4, 1, we're represented by this point, -3, -4 thirds, -2, -2, -1, -4. So let's go ahead and connect these dots. How we connect these dots is by a little line, a curved line that is not going to pass y's 0 and x's 0 here and here. It's not going to go past these lines. So if we were going to graph the bottom, or the top part of it, we would go starting from the top, going down, if I can, as nice as I can. I'll try to hit all the points. And there is the graph of an inverse variation. The one key here, though, 0, and what is this? This is no solution here. And why is that a big key? Because if I let this x be 0, what is a number? Any number divided by 0. You cannot divide by 0, so we have no solution. And that is why that our graph does not pass here and here. So let's come up with an equation for this. First things first, let's find our k. How do we find our k? By just multiplying our x and y together. So we have x times y equals k. So let's pick an x and y. I'm going to pick -4, -1. So we have -4 times -1, that equals 4. So my k is 4. So let's plug it in to y equals k over x. So we have y equals, and what is k? It is 4, so it's 4 over x for your answer, for your equation. Let's try some more examples. Now we are asked to determine whether each table or equation represents an inverse or a direct variation. Now, I want to give us some hints up here, where inverse variation is found by multiplying equals the same number, and direct variation is dividing equals the same number. So I'm always going to start off with inverse variation. Now, what are we multiplying? We're going to be multiplying the x's and the y's to see if it is a inverse variation. So 6 times 3 is 18. So now if I multiply 8 times 4, that better equal 18. Well, 8 times 4 is 32. So now 18 and 32 are not the same number, right? So what do we have left to pick from? It has to be direct variation. Well, let's try it real quick. How about 6 divided by 3? That is 2. 8 divided by 4 is 2. And 10 divided by 5 is 2. So it must be direct variation. So it is direct variation. Remember, it is y equals kx. In order to write our equation, we have to figure out what k is. Well, what did I take times 6 to get 3? What did I take times 8 to get 4? What did I take times 10 to get 5? Well, you took it times 1/2 or 0.5. So I'm just going to plug that k in for my equation, y equals kx. So I have direct, and your equation, if you wanted to, would be y equals 1/2 x. Number 2, again, start by multiplying. See what that gives us. 1 times 2 is 12. 2 times 6 is 12. 3 times 4 is 12. So it must be inverse variation. And if we were writing it, we want to write it y equals k over x. You'll like how to write these because we have y equals, and you already find your k when you multiply. You already find your k when you multiply, so 12 is going to be your k. That's going to go over x for your equation of the table. Here, we want to see if the equation represents a direct or inverse variation. What we want to do here is to get y by itself. Notice our direct and inverse, y is always by itself. So we are going to get y by itself. With number 3, what is attached to y? There is a 2 attached there through multiplication. How do you undo multiplication? We have to divide. So we divide by 2. We get x over 2 equals y. Now, what does this look like? Yes, it kind of looks like an inverse variation where we have k over x. We have a fraction, right? But is x on the bottom? No, it is not. And as a matter of fact, how could we rewrite this x over 2? Could we also go 1/2 x? Or could we also go 0.5x equals y because we are dividing it by 2? We could. So x really isn't on the bottom. The number really isn't on the bottom. It just looks like it's on the bottom. So we have a direct variation here. How about number 4? We want to get y by itself. What is attached to the y? We have an attached -2 and an x, so we want to divide both sides by -2 and x. We will be left with y equals 20 over a -2x. Now, you don't have to simplify, but I'm going to simplify this to be y equals a -10 over x. Now, why does x stay on the bottom? Because x can't divide into 20. You don't know what this x is, so x stays on the bottom. Since x is on the bottom, ladies and gentlemen, what is this? Notice how x is on the bottom of the fraction, so it has to be an inverse variation because x is on the bottom. Again with 5, what do we have to do to get y by itself? We have to divide by 0.5. We're dividing by 0.5, and so now we have x over 0.5 equals y. Well, it looks like it's inverse variation to me, but is x on the bottom? X is not on the bottom. 0.5 is on the bottom, and if you wanted to, you could almost rewrite this problem as, or you could rewrite this problem as 2x equals y. Now it looks more like a direct variation because it is a direct variation. And then 6, what do we have to do with 6? We have to get y by itself. Is y already by itself? Yes, it is. So what is this? This is a direct variation. And you are done. And that does it for section 11.1, Inverse Variation Part 1. Good day.